So I've gone through the measurements and calculations, so this is what sort of reveal. The mass was 81.49 grams. As with dealing with any type of measurements, 81.4 I could actually get off the machine itself, but the 9 is an estimated digit. So it looked like it was just shy of 81.5. The diameter of it was 12.575 millimeters. Now I got that level of precision because I was using a device known as the vernier caliper. It looks like this. I know there's at least one student in the class who knows how to use it. I did do an estimation there at the end because normally you don't have estimated digits in this one, but I have a technique that I think works reasonably well. At least I believe in it. So I have my mass, I have my diameter, just divided by 2 and then converted. Notice if I divide this by 2, I get 6.2875, but I put it down into centimeters. Now, why centimeters and not meters? Well, when it comes to dealing with density, you have two sets of tables often. You'll have grams per cubic centimeter, or you'll have kilograms per cubic meter. Usually, there's a lot of tables that still are in grams per cubic centimeter, and so that tends to be the way I go. I will adjust that when I look back at the lab just to see what I asked for there, but I think I asked for grams per cubic centimeter. The length, again, use the vernier caliper. I came up with 82.525 millimeters, and then to convert to centimeters, just move the decimal place over one spot, 8.2525 centimeters. So those are all the measurements that I need to make in order to be able to figure out the volume of this thing. And of course I did that already. So I know that for volume of a cylinder, the formula is pi r squared L. And so, well, I just found the radius, I found the length, and so I plug in, I came up with 10.25 cubic centimeters, or cc's. That's the same thing as a milliliter. That'll come in handy in the part B, but cubic centimeter is the same thing as a milliliter, and I got 10.25 cubic centimeters. Why cubic? Well, because my radius here was in centimeters and I squared it. My length was in centimeters, so I had 3 centimeters there multiplied together. In other words, cubed. Now, density is mass over volume, and if I do that division, I got 9.75 grams per cubic centimeter. Now the question is, what can I do with that information? Well, one of the things is I can help identify the material. I then went to the density tables, so this is what I started with, and tried to see what of the common substances, what comes closest to 9.75 grams per cubic centimeter. And the device, what I actually came up with was iron at 7.87 grams per cubic centimeter. So my guess is this is iron. I know it's not going to be any of the exotic things, or my guess is it's not any of the exotic things. It's going to be some common standard material, and iron actually makes some sense here. So that's part A of finding the density. Next video, we'll talk about part B and other things that we can do.